Yeah, this one for small, this one for big board. Okay, so any question for this one? For the setup the timer, if you finish, then put the yes mark under your name. If you have any questions, let me know. Put the no mark, or you can unmute your the microphone. You send a message to me. Okay, so this is for the big board. This one for big. Oh, sorry, this one for small board, and then this one for the big board. Okay, the notepads plus is for the big board, and in my account compiler is for the small board. Okay, so a student give me the feedback. So yeah, please let me know if you work on if you finish the code for the setup timer. Okay, for the setup timer, and put the yes mark under your name. Yes, I got that email, the message from the student. Yes, only difference between the big board and the small board is the one uses the timer module 1, another one uses timer module 0. Okay, so you can see here, this is the T1 CCP0, this one for the small board, and then for the big board, you use a T0 CCP0. Okay, so small board use the module 1, and the big board use the module 0. Only a difference here, the module. Okay, so of course here you can see here timer 11111. Okay, so for the small board, you can change this one to the 1. And for big board, this one should be the 0. Okay, the reason is we use the module 0. Okay, so once finished, please put the yes mark under your name. If you need more time, yeah, put the no mark so I can wait. So I can wait for you. Okay, so you finish the code and please change the mark to the yes mark. Okay. Okay, so here no mark. Okay. Uh, of course you need to finish the setup the UART. I think you should know how to do this one. Okay, so set up the UART. You have to know your system the frequency. For the small board, yeah, the first statement in the our main function is set up the 123G underscore 80 megahertz. So which means our the clock, okay? So our clock frequency is 80 megahertz. Okay. Okay. So based on that one, you need to calculate the UART, the power rate divider, the divider value for the integer and the fractional part. Okay. Now let's just discuss about the setup GPIO. Okay, let's check the which pin we use for the small board. So small board, we're gonna use the 2 pins for ultrasonic. So one is the PL4 and the P. Oh no, this one's for big board. Okay, so for the small board, we're gonna use this the 2 pin, the PF2 and the PF3. Okay, so we're going to use the PF2 and the PF3. And we also use UART. UART with the PA, the 0, and the PA1. Okay, so PF2, this is the connect to the echo. So we connect the PF2 to timer and the PF3 to the trigger. So PF3 is output. Okay, so this one connect to the timer. Okay, so that one connected from the echo pin. Okay, so here we use the port A and the port F. Okay, then here we are not use the PDF. No, we are not PD7. No, and the PF0. No, so we don't need to unlock. And all the signal is the digital one, so we don't have any analog signal, so we can skip the step 3. Then port control register. Okay, so you have to configure the port A. Okay, A and B for your UART, but now here I just show you for the timer PF2. So for the PF2, the GPIOF port control register. Okay, so what is the port control register for PF2? So let's go down here. PF2 port control register is 7. Okay, then F2. Okay, so PF2. Okay, then here you also need to do for the PA0. Okay, so one for the PA0, another one for the PA1. Okay, then you have to enable all the pins PA0, 1, and then PF2 and 3. Oh, we had one output pin, right? PF2 is output pin. Oh, hold on. No, sorry. PF3. PF3 is output pin to the trigger. So don't forget. Okay. Then we don't need to set any put up or down resistor or open the drain. So we can skip the step 7. Then the step 8, you need to enable all the pins. Okay, so this is for the small bore. And then let me check this big bore. The big bore use the PL4 and the 5. And also PA0 and the PA1 is for the UART. Okay, so PL4, let me see. PL4 is echo. So connect to timer. This one is from echo pin. Then PL5 is output. okay, to the trigger pin. Okay, so for the big board, you need to turn on the clock for the port A and L. Okay, then you need to set up the, let's see, do you need to unlock? No, you don't need to unlock, okay. Then you need to configure the port control register for the PL4. Okay, so the value for the PL4 is the port control register is 3. So PL4 is 0x3. Okay, then you also need to configure. Okay, so this runs for the UART. Then we also have the one pin is output. The output pin is the PL5. Okay, then you need to enable all the pins. So first one, we need to enable the A. And then enable the port L. Okay, so this is for the big board. Okay, so give me the feedback. You finished your setup GPIO and put a yes mark under your name. Okay, so we still have 2 students. You're gonna finish. Okay. So once you finish, please change your the no mark to yes. Okay. Okay, good. So everyone finished it. Then scroll up to the main function. Okay, so to the main function, in the main function, this infinity loop, the first one we're gonna trigger, we're gonna send the trigger signal to the ultrasonic module. Okay, so that one just a regular output pin. Okay, so we're gonna use the GPL, the address in the mask. Okay, okay, so change this one to okay. So this is the trigger, TRIG, the trigger. So depend on the which one you use, or the which board you use. If the small board, the trigger pin is connected to the PL5. Okay, so that one is for the small board, and for the big board, oh PL5. Sorry, PL5 should be the big board because the small board doesn't have L. Okay, and for the small board, the trigger pin we connect to PF3. Okay, so let me see PF3, and how about timer? Timer is PF2. Okay, so PF3. Okay, so we're gonna set to the one uh the GPL addressing the mask for the trigger pin. Okay, then the trigger pin you need to change it, okay, GPL and the pin. Okay, so for the small board is PF3. Okay, so first step we're gonna set the trigger pin to the low. To the low, which means we gotta set the trigger pin to the low. Then waiting for the 500 millisecond. Then we're gonna put the trigger pin to the high. Okay, you cannot put the one here. Okay, because we already used the address. We used the GPL address in the mask, so you cannot put the one here. So which value you have to use depend on which pin you use. Okay, so if you use the small board, then you need to put the bit 3 or pin 3. If you use the big board, you have put the pin 5 or P5. Okay, to trigger that bit to 1. Okay, you can just write 1. If 1, you can trigger the bit 0 to 1. But here no, we use the hardware mask for small board. We change it. We use the hardware mask on the bit 3. So only the value you assign on bit 3 you can change it. Okay, so all the rest of the bits not changed. Okay, so here you had to write another value. Okay, so then we call the hardware timer for the 10 microsecond delay. After the 10 microsecond delay, then we're gonna drop this trigger pin to the low. Okay. Okay, so here trigger pin. The first step, we're gonna set the trigger pin to low. So we're gonna set this one to zero. Then we're gonna call the timer, okay, to wait for the 500 millisecond. Then I'm gonna set that pin to the one. Okay, set pin to one. Okay, which pin we use for trigger? Then you have to put the pin number here or bit the number here. Then wait for 10 and then 10 microsecond. Then we're gonna set the trigger pin to low. Okay, so assign the 0 here. Then we call the function. We call the function to measurement our pulse width. Right. So now scroll down to the code to here. We had one function called the measure the D. Okay. Okay. So here, how to capture our first edge? The first one, we need to clear. Okay, so we need to clear the interrupt the bit. Okay, just in case the previous one the trigger. Okay, so we're gonna clear. So how to clear it? For the small ball, we use the T. See, check here. Small ball, we use the T1. So it's timer 1. Big ball use the timer 0. Okay. So timer 1. So interrupt clear register. So which bit I already define in my defines. So here, this one for the timer interrupt the clear the register. So we're gonna clear timer A. Okay. So we just write this value to the ICR, this is the register, then they will automatically clear the interrupt the flag for the timer A. Okay. Then here we need to continue to check the RIS, this is the row interrupt, the status, this register, to check which one, to check the capture event. Okay, if our echo pin, after they send the ultrasonic out, the echo pin, they will drive the echo pin from the 0 to 1. So that one is our first capture. Okay, so we need to wait until we get the first capture. Okay, so check which bit is this one, capture A event integer, the interrupt. Okay, so I'm gonna check this bit. If the result after the result is the okay, so if the result is not equal to this bit, which means the event the capture timer A capture event is 0. So if the 0, then we still wait, okay, until this bit equal to 1. Okay, so this is step 2. Then step 3, we got the first capture. Okay, so if we got the capture, then we're gonna finish this the while loop. Okay, then we're gonna jump to the step 3. So step 3, we got the first capture. Then first capture, we're gonna store that value from the timer 1. Okay, from timer A, the capture the register. So we got first capture. And next one, we're gonna go back to do the step 1 again. So clear this the interrupt. Okay, so we got clear interrupt and waiting for the next capture. Okay, and waiting for next capture. So once we get another capture signal, that one should be the falling edge. Okay, so that one is our second capture. So second capture, we're gonna load we're gonna store the capture the value to the low edge list variable. Okay, so now we got the two captures. Okay, so then we have to calculate the delta t. Okay, so delta t is the pulse width. Okay, no, here distance. No, sorry, we just return the delta t, not distance. Sorry, I need to change my code. So we're gonna return the delta t. Okay, so usually this is the formula. The delta t is equal the high edge minus the low edge because the timer is the countdown mode. So first capture the timer value should be larger than the second capture one. Right. Okay, so let me draw here. So this is timer. So timer will continue count down to zero. Once it count down to zero, then they're gonna reload and continue to count down. Okay, so this timer. Okay, so let's say we had a capture. Okay, so let me change color. Okay, so let's say when the timer count down to this value, then we got the first capture. Okay, then we have second captures here. Oh, second capture to here. Okay, so this is the first capture. Okay, then we have the second capture here. Okay, so you can see the first capture, you're the timer, the number or capture number is larger than the second capture. Yeah, good. Okay, in this situation, good. But can this one happen? Let me show you. Oh, can I move it? Oh, okay, I can. Okay, so let me change the color. So see what happened. Okay, if I got the first capture here, if I got the first capture here, this is my first capture, and second capture here. Okay, so this is my first capture. Okay, you can see here my first capture and the second capture. Then see what happened. Your second captured value is larger than the first capture, all right? Then if you use this formula, we calculate delta t is the high edge minus low edge. But now you can see the second capture low edge is higher than the high edge. What does it mean? You get the delta t. The delta t is a negative number. Oh, okay. The t is not negative number. Okay. So what does it mean the capture high capture minus the low capture? Which means we're gonna count. We can calculate how many count between at least the two captures. Okay, so the value should be this one from here to here. Okay, so we want to know. Okay, so how many counts between the first capture and the second capture? Then times the your the all the uh, the one of the timer, the frequency. Okay, so then check it here. If the second capture, which means the low edge, is larger than the first capture, then we cannot use this formula. We cannot use the high edge minus low edge. Okay, then how we can count, how we can get the count between the first capture and the second capture? It's still this range. Okay, but you can see here the range is here plus this one. Oh, let me change. Oh, can I erase it? Undo. Okay. Okay, so it should be this range plus this range. Okay, then what is this value? What is this value? Okay, so this value, that value is our load value, right? So remember, the load value is the 0x 6f. Okay, so that one is our load value. Okay, 0x then 6f. Okay, and what is this value? Oh, sorry. What is this value? That value is 0 when we count down to 0. Okay, so here you cannot directly calculate the delta t. Okay, you cannot directly calculate the delta t like this one code. No, you check. Okay, if your high age is larger than the low age, yes, then you can use this one. Then times the one of the timer the frequency. Okay, otherwise, which you mean the second capture larger than the first capture, then you have to add the first capture value plus this distance. This distance is the FFF, that's 6F minus your second capture value. Okay, so I'm not give you a code. You have to, I just give you pseudocode here. If this is pseudocode, okay, this is not a C code. Okay, so here, let me repeat again. Okay, so the delta t is actually the count. Okay, so how many count between these two capture times your period per cycle? Period per cycle is 1 of f. Okay. So if the first capture larger than the second capture, yeah, I just directly subtract, okay, from the first to the second, and we got that is the count value, and times your PRT. Okay. But you find if the first capture less than the second one, which means this number less than here, so you cannot directly subtract. If you subtract, you got the negative number. Okay, then this unsigned. Okay, actually, if you subtract, you're gonna get the the count value is not between these two capture. It's from here to this capture. So what do you mean this value? Okay, so incorrect. So yeah, so otherwise, okay, how to get to the count between the two capture is this range, okay, so from 0 to your first capture plus this range. This range is the second capture between the second capture and the F. Okay, so this range plus this range, okay, is your counter value between your first capture and the second capture, and then this one times the period per cycle. Right? Should be a period of cycle, not the per. Sorry. Okay, so then you get the delta t. Then we return the delta t back to the function. Okay, so here, give me the feedback. You finish or if you understand the measure t, this function, how we get the capture from the timer register, and how to calculate the delta t. If no question, then put the no mark. Okay, or you finish. Okay, hold on. Let me say, if no question and you finish the code, then put the yes mark. Okay, so if you're not finished, and then if you had any question problem, then give me a no mark and send your question to the Zoom chat, or you can unmute the microphone and let me know your question. Okay, so you finish the code and no question, and put the yes mark. You still work on the code, then put the no mark. Okay, then if any question, then unmute your microphone or type your question in the Zoom chat, just let me know. So I have 11 students give me the feedback. You finished the code. How about other student?
So, Professor,
Yes.
we're talking about subtracting the low edge from the maximum value. I just don't understand what would I just type in the maximum value minus the low edge?
Okay, so here, your first capture we store in the high edge, right? And the second capture we store to the low edge. Okay, then this wire is the timer. The timer will use the countdown mode. So what you mean the timer always count down from the 6F to the 00. So when they count down, if any capture happen, they can load the counter value to our capture the register. Then we store capture register to these two value. Right? Okay, so check it here. The situation is our first capture, for example, first capture is here. Then our second capture is here. Okay, so you can see the first capture, the counter value larger than the second one. So how many count between these two capture? We just the first capture subtract, which is the second capture. Then we can get the count between these two captures, right? But the counter, this counter is a free running the counter. So what you mean? They continue to count down to 0 and reload and continue to count down. So we cannot guarantee every time when we capture the first one and the second one, the first one always larger than the second one. We have one situation is that this example, our first capture is here. Then second capture. So when we got the second capture, the counter is already reached the 0, and then they reload this one to FFFFF and continue to come down. So we have another situation is that our capture is here and the second capture is here. So what does it mean? We can find here, second capture, the counter value is larger than the first capture. So this is a formula. This formula, we cannot use it. We cannot use the high edge minus the low edge because we're going to use this value. If you use high edge minus low edge, here, the high edge is less than the low edge. If you subtract, then you get the negative number, right? This less than the second one. Okay, so we need to change this. We need to change this the formula. But the best idea is we want to count. Okay, how many count between these two capture? Then from this the graphic you can see here. Okay, so how many count between two capture? Is your first capture the number from here to 0 plus this one? This one is the from F to your second capture value. Okay, so this is linear algebra, so you should know how to do that. Okay, so what's this value and what's this value? Okay, then you just add these two value together, add that two value together, and the time your period of the cycle. then we can get that out the delta t. The delta t is the this one. Delta t is the echo signal. Okay, so this is delta t. Okay, the result is the second. Yeah. Okay, so second. So then here, this delta t, we cannot use the unsigned. We have to use double. Okay, then change your measurement the d to the double. Yeah, I will update my my website. Okay, and here measurement t, not the d. Okay, go the yeah. So the measure t and the return the data type double, and then change this one to double, the delta t to double. Okay, the reason is that our previous of the cycle is one of the frequency. What the frequency we use for small ball is 80 the megahertz. Okay. No, not 60 megahertz. Okay, so you can see here, this one, and our code, we change the CPU, the frequency, we change the system clock to the 80 the megahertz. Okay, so your the system clock is not 60 megahertz, it's 80 megahertz. And then we double check with the big ball. For the big ball, yeah, the big ball also I changed that one to the 80 megahertz. Okay, so not the 16. Okay, so it's 80 megahertz. Yeah. Okay, so change the function. Okay, change this function to the double the measure t. Okay, so let me change here. Also change this one to double. Okay, so that one is the pulse width. So pulse width is double. Okay, so in your main function, change your pulse width to the double, and also change this function, the definition. Oh, is a measure t, yeah, and also double. Okay, so here this one should be the t. So we got the pulse width. So then, what is the distance? Distance is equal our pulse width times your velocity, right? The speed of the audio in the air, right? Okay, don't forget that one should be the centimeter, okay? Centimeter. Then you need to divide by 2 because that this the first width is the how to say the audio back and forth, the 2D. Okay, so we need to divide by 2. Okay, then we can display the distance on the screen. Okay, the first width. Let me see. I print out this one, the first width, this one, and I display the first width in the first width cannot be the D. Should be the F. Yeah. Okay. Okay. So the first one is the I value, and the second one is the percentage F. We're gonna display all the first width in the centimeter. First width is not the centimeter. First width is the T. Yeah. The how many second? And distance in the centimeter. Sorry. Okay. Yeah. So put this one 0.2. So which mean after decimal, I just need a 2-digit. Okay. Yeah. Let me change my code. Okay, so how about the main code? You finish the main code and no any question, then put the yes mark. Okay, so you finish the code and put the yes mark. Okay, so if you finish the code and try to compile it, and if no question, then put a no mark under your name. So let me know you finish that is the lab. Not to finish. Okay, yeah, still need to connect the board. Yeah, at least you don't have the question. Okay, you know how to do that. Okay. You got the arrow. Some students tell me you got the arrow. Yes, the arrow because like this one. You still need to fill this the value and here. Okay, you can see you still need to finish that one. And you also need to finish your code for set up the UART. The speed of the air. Okay. Okay. So here, reading the requirement. If you forget again, the reading requirement here is the ultrasonic sensor, the data sheet. Uh, okay. So this one, 340 meter. This is meter. So you need to convert that one to the centimeter. Okay. 340 meter per second. Okay. So you need to convert that one to the centimeter. And divide by 2, yes. Okay. So you want us to fill the blank right now? Oh, depend on you. Okay. You just had to know. Okay. So if you want to fill the blank, that's fine. Okay. Or you want to do this one later, that's fine. Okay. So you just need to know. You have to know. Okay. What trigger, right? Which pin you connect to trigger? PF3, and here's F, and it's a pin 3. Then use the big board is the PL5, so this one should be the GPL and the 5. Okay. And also, yeah, you should know how to do this one. Okay. And also finish the configuration for the setup that you want. Okay. And also this one is pseudocode. This one not the correct code. Okay. So also need to implement this one. The periods of the cycle is one of the frequency. What the frequency for this one? And the system clock I changed to 80 megahertz. Yes, okay. See here, this is 80 megahertz. Okay, so your system frequency is 80 megahertz. So times one of the 80 mega. Okay. Yes, you need to divide by 2. Okay. You can check here. This is a formula. The range is your high level time. Your pulse. Actually, this one is your pulse, the time. Times this velocity divided by 2. Okay. So you can see here, yeah, divided by 2. Or you can use this formula. This formula say if you convert your pulse width to the microsecond, okay, to the microsecond, okay. So microsecond, then you divide by the 58, then you got a centimeter. Okay, so this one is your pulse width. If your pulse width is microsecond, okay, it's a microsecond, and so which means your data t you need times the let me see, you had to time to 1. After 1, you have to 60. Okay. So convert that one to the microsecond. Then microsecond divided by 58. Or you can use this one. Okay. So this one is the per switch in the second times this number, but this number is 340 is meters. So you convert this one to the centimeter and then divide by 2. Okay. Get the center result. Okay. Okay, so far here we already, I think in this class we already discussed the lab 1 to the 10. Okay, so and for the lab 10, oh, let me see, do I have any exercise? No exercise, sorry, any exercise experiment? Oh no, yeah, this one is pretty easy. I just ask you the first one. The UART, you need to configure UART. Okay, the baud rate is this bit 3400 and 38400 and 8-bit, one stop bit, and no any parity check. And the second one, you're gonna finish the code to determine the sensor. Okay, the sensor, the signal, the press width. And third one, you're gonna use the party. Okay, so use the party. And once you use the party, you should see there's a message. Okay. Of course, the message is different because I already changed your printf function. Okay, the UR printf function. So whatever should be like a 1 and your pulse width in a millisecond or second and your distance. Okay, so check the distance. Then how to test it? You just put the one textbook, okay, on the front of the ultrasonic sensor. Then use the one the ruler to check. Okay, so for example, you put your book, okay, close to your sensor in like the 15 centimeter. Use the ruler. Okay, so make sure your book is close to the 15 millicenter. Then check your reading. Check the this result on the party. Should be the close to the 15 centimeter. Okay, if you find you out you put your any object in like the 16 centimeter, but your result is not this value, then go back to check your code. Okay, there's something wrong, especially for maybe a calculation. You get the incorrect calculations. Okay. Okay, if no question, then I'm gonna stop here. Before we leave, please don't forget to sign in your name in the Zoom chat. Okay, and then next week, I think next week is holiday week, right? We don't have class. So let me double check. But I remember we don't have class next week.
Yeah, classes are canceled next week.
Yeah, we don't have class next week, but I still provide office hour on Tuesday, Thursday, 9 to 10. Okay, so same the Zoom password and the Zoom ID. If you need my help, okay, so next week, Tuesday, Thursday, I still have office hour, so you can log into my office hour. Okay, so I can help you to solve the problem. Okay. Okay, so if no question, then we can stop the class here, today the class. And also, let me see. So after, hold on, let me see. After the holiday, we still have the 1 week, 2 week. Oh, we just have the 1 week, the class. And then we have another week for the final. Okay, so my final always the before the final week. Okay, so yeah, okay. So after holiday, we have the one lecture week. For that lecture week, I just help you to solve the problem. I don't have the new material to teach you. Okay. Then after that week, we're gonna have the final the exam on the Wednesday. So on a Monday, we're gonna go over for the final exam. Okay. Okay. So if no question, then you can log off. You have question, you need my help, then stay here. Okay, you can unmute your microphone, or you can send me your TeamViewer ID. If you want me to check your code, and send me your TeamViewer ID and password. Okay, so let me help you. Okay, so otherwise, yeah, I can say have a good night. Okay, so any student you need my help? If you need my help, put a yes mark under your name. Okay, good. So I know I have one student you need my help. Okay, two students. Okay. Okay, David. So what's your question? Oh, thank you. Okay, good night.
It was on Lab 7. I'll send you my team viewer right now.
Okay. So lab 7. DC motor. Okay. Okay, I got your team viewer ID password. So Davey, Omar, you're on the next one, okay?
Yeah, so let me open.
So give me a second. Let me type your ID password.